The Sukhoi Su-24 Fencer is a twin-engine, supersonic, all-weather strike aircraft designed to penetrate heavily defended airspace at very low altitude. Developed by the Soviet Union during the height of the Cold War, the Su-24 was built to deliver conventional and nuclear weapons deep behind enemy lines while avoiding radar detection through terrain following flight. It was created in response to NATO's growing air defenses and the need for precision strike capability in any weather, day or night. Even decades after its introduction, the Su-24 remains a significant platform in modern air warfare due to its range, payload, and ability to operate in contested environments. 2. Origin and development history. The Su-24 originated in the Soviet Union and was developed by the Sukhoi Design Bureau. The program began in the early 1960s, with formal development accelerating around 1965. The aircraft first flew on the 2nd of July 1967 in an early prototype form, with the definitive variable sweep wing configuration flying later in 1970. The Su-24 was developed to replace older Soviet tactical bombers such as the Yak-28 and Il-28, which lacked the speed, range, and survivability required against modern air defenses. It also represented the Soviet answer to Western aircraft like the General Dynamics F-111, which had demonstrated the effectiveness of low-level, high-speed strike operations. 3. Design philosophy and airframe. The Su-24 was designed around a single core philosophy: low-level penetration and high speed under all weather conditions. Its most distinctive feature is its variable sweep wing, allowing the aircraft to optimize performance across different flight regimes. Wings are swept forward for takeoff, landing, and low-speed flight, and swept back for high-speed dash at low altitude. The airframe is constructed primarily from aluminum alloys, with steel and titanium used in high-stress areas. No stealth materials or shaping were employed, as the aircraft predates stealth technology. The Su-24's side-by-side cockpit layout, rare in fighter aircraft, was chosen to reduce crew workload during complex strike missions and improve coordination between pilot and navigator. For engine and propulsion system, the Su-24 is powered by Saturn Lyulka AL-1 F3A afterburning turbofan engines. Each engine produces approximately 7,600 kilograms for 16,750 lb-f of thrust, with afterburner, and around 4,000 kilograms for 8,800 pound dry. This engine configuration provides the thrust necessary for sustained low-altitude flight at high speed while carrying heavy weapons loads. The thrust-to-weight ratio is moderate, reflecting the aircraft's role as a strike bomber rather than an air combat fighter. The engines prioritize reliability and power over fuel efficiency or agility. 5. Speed and flight performance. The Su-24 has a maximum speed of approximately Mach 1.6 at altitude, equivalent to around 1,700 kilometers per hour, 1,055 miles per hour. At low altitude, maximum speed is reduced to roughly Mach 1.2, optimized for penetration rather than interception. Typical cruise speed during strike missions is around Mach 0.85. The service ceiling is approximately 36,000 feet, 11,000 meters. Rate of climb is estimated at 9,000 to 10,000 feet per minute. Maneuverability is limited compared to fighters, with handling optimized for stability rather than dogfighting. 6. Range, endurance, and fuel. The Su-24 has a combat radius of approximately 560 to 615 kilometers, depending on altitude, payload, and mission profile. Ferry range with external fuel tanks exceeds 2,800 kilometers. Internal fuel capacity is approximately 11,700 kilograms, unusually high for an aircraft of its size. The Su-24 is equipped with aerial refueling capability via a retractable probe, allowing it to conduct extended-range strike missions well beyond national borders. 7. Fuel consumption and operating cost. Exact fuel consumption figures are not officially published, but estimates place fuel burn at several thousand kilograms per hour during low-level operations. Afterburner use significantly increases. Consumption, operating costs are high due to twin engines, complex variable geometry wings, and aging avionics. Maintenance demands are substantial, particularly for the wing sweep mechanism and navigation systems. Compared to modern multi-role fighters, the Su-24 is labor-intensive to operate and maintain. 8. Avionics and sensor systems. Early Su-24 variants were equipped with the Puma navigation, an attack system centered around the Orion, a terrain-following radar, a mechanically scanned radar optimized for low-altitude flight rather than air combat. Later variants, particularly the Su-24M, received upgraded navigation, laser designators, and improved electronic warfare systems. Sensor fusion is limited by modern standards, but automation significantly reduced crew workload for terrain following and weapons delivery. Defensive electronic countermeasures include radar warning receivers, jammers, and chaff and flare dispensers. 9. Weapons and payload. The Su-24 carries all weapons externally across 8 hardpoints, with a maximum payload of approximately 8,000 kilograms. This includes conventional free-for-all bombs, cluster munitions, laser-guided bombs, and air-to-surface missiles such as the KH-23, KH-25, KH-29, and KH-59 for self-defense. It can carry short-range air-to-air missiles like the R-60 or R-73. Though air combat is not its primary role, the aircraft is also capable of delivering tactical nuclear weapons, a key element of its original mission. 10. Stealth and survivability. The Su-24 has no stealth characteristics. Its radar cross-section is relatively large. An infrared signature is significant, particularly during afterburner use. Survivability relies on low-altitude terrain masking, speed, electronic countermeasures, and defensive aids rather than signature reduction. This approach was effective against Cold War-era air defenses, but is increasingly challenged by modern integrated air defense systems. 11. Real-world service and combat use. The Su-24 has served with the Soviet Union and Russian Federation, as well as countries including Ukraine, Syria, Algeria, Iran, and Kazakhstan. It has seen combat in Afghanistan, Chechnya, Syria, and the Ukraine conflict. Operational evaluations consistently highlight its accuracy in strike missions and ability to operate in poor weather, while also noting high maintenance requirements and vulnerability without escort or suppression of enemy air defenses. 12. Cost, production and global impact. Approximately 1,400 Su-24 aircraft were produced between the early 1970s and the 1990s. Unit cost figures were never publicly disclosed, but were significant by Soviet standards. The Su-24 played a major role in shaping Soviet and Russian strike doctrine and influenced later designs, such as the Su-34, which was developed as its modern replacement. 13. Strengths and weaknesses. The Su-24 excels in payload capacity, low-level penetration, and all-weather strike capability. Its weaknesses include limited survivability against modern air defenses, lack of stealth, and high operational complexity. Aging airframes and avionics further constrain its effectiveness. 14. Final verdict. The Su-24 Fencer represents a pivotal chapter in military aviation history. It embodied East Cold War strike doctrine, focused, powerful, and uncompromising in purpose, while increasingly obsolete in modern high-threat environments. Its legacy endures as a benchmark for deep strike capability and a platform that shaped decades of tactical air warfare.